Now that we've talked about the hydrologic cycle, let's see the things that water actually does. We're going to start with groundwater. Groundwater is exactly like it sounds. It's water in the ground. Okay, so this is how water transports through soil and sediment from one place to another. Now, a couple of things that affect how it is that the water is able to pass through. First, we have porosity. Porosity is the open space within the soil or sediment. It's how much volume there is that the water can be in. Generally, a greater porosity means a greater potential to store more water. The more holes there are, the more water the ground is able to actually hold. Okay, some things that affect porosity. We have particle size, shape, and sorting. Okay, so with particle size, smaller pieces can fit together better, okay, filling in smaller spaces. So larger pieces that will lead to greater porosity. Okay, if we have nice round shapes, then there's going to be a lot of holes in between, okay, and so the shape will affect the openness of the space. And last, sorting. Okay, so what we mean by sorting is the different sizes of particles. Okay, if we only have just really big fist-size pieces of rock, we're going to have lots and lots of open space for the water to flow through. On the other hand, if we've got small sand and smaller pebbles and then big rocks, then the sand and the pebbles will fill in that small space, making sure that water isn't able to flow as well. Okay, so if we have well sorted stuff with round shapes and big pieces, then the ground is going to have a lot of porosity. The other piece is permeability. Permeability is how well that water can actually flow through the pores. Okay, if you've got a lot of open spaces, but they're not actually connected, then the water can't move from one space to another. Okay, so permeability is how well the holes fit together and therefore affects the overall flow of the water through the sediment. Okay, so something that can affect this is the packing and the connectedness. Okay, if it's very, very well packed, and it is not well interconnected, then water isn't going to flow through. Okay, so as we look at groundwater, we have two regions. Water that is in this region where the soil is saturated. Okay, this is what we refer to as groundwater. Okay, so groundwater is in the saturated zone. Remember, saturated. We've used this term a lot. It means completely full, holding as much as possible. Okay, so we have the saturated zone, and any water in the saturated zone is groundwater. Okay, above the saturated zone, we have the unsaturated zone. I know, it's very clever. Okay, water in this region is known as soil moisture. Okay, so soil moisture occurs in the unsaturated zone. Groundwater occurs in the saturated zone. The boundary between the saturated and unsaturated zone, this is the water table. Okay, so if you can dig down into the water table, then you're now into the saturated zone, and you may be able to start pulling water out. Okay, so wells are actually dug down into the saturated zone below the water table. Now, the depth of the water table is actually determined by the amount of precipitation and the overall climate. If it's a very, very wet region, then the water isn't able to flow out easily, and so we get a very, very high water table. For example, in marshes and swamps, we have zero depth to the water table. It's right there on the surface. Whereas in deserts, where there's very, very little precipitation, it can actually be hundreds of meters below the surface. At perennial lakes and streams, the water table, the ground actually dips below the water table. So the lake is actually above the water table. It's almost defining the water table. And generally, the water table does rise and fall with the surface topography. So if we get a hill, then the water table along the hill is usually higher, and so on. When dealing with groundwater, we have to look for aquifers. So an aquifer is a reservoir of fresh water And the area that has this water has a high porosity and high permeability. I know that when I was a kid, first thinking of aquifers, I imagined them to be these giant underground caves that were full of water. That is not what's actually going on. It's still all rock and sediment and other stuff. It's just that this region has a high porosity and high permeability. So as we draw water out, new water is able to flow in without a problem. So we can keep pumping water out. Okay, so an aquifer is a reservoir of groundwater in a region with high porosity and high permeability. Now it's possible to form what is referred to as a perched water table. A perched water table occurs when we have a region of low porosity and low permeability with other material around. So we end up with this region of saturation above this low porosity, low permeability region. Okay, so we have kind of a fake or false water table above because of the stuff below. Okay, this can actually lead to a spring. If you've ever seen a spring just coming straight out of the mountain, this is what's happening. Okay, we have a perched water table, and then the water is leaking out of the mountain at that region. Okay, because of the way that these springs work, geologists can actually use the location of springs to figure out where fault lines are. So we have this bedrock with low porosity and permeability. Regions where it is broken can actually lead to springs, which you can then trace and figure out exactly where the fault is. All right, here's our second question. A soil with rounded particles of similar size will have a higher porosity than a soil with rounded particles of various sizes because A, it will have a higher permeability, B, water flows more easily through rounded particles, C, smaller sediment grains will fill in the open pore spaces between larger grains, or D, poorly sorted sediment will have more open pore spaces. Go ahead and think about it, and we'll discuss it in just a little bit. All right, so the correct answer is C. Okay, if we have poorly sorted material, then we have big pieces and small pieces, and the small pieces will fill into the holes between the big pieces, which decreases the overall porosity and permeability. So the answer is C. All right, so what are some of the things that groundwater does? Groundwater can lead to land subsidence. It will form caves and caverns and can also lead to sinkholes. Okay, so if we have an aquifer and we pump water out of that aquifer very quickly, this can actually cause the above land to actually sink down. Okay, this is what is referred to as land subsidence. Okay, so specifically, if we have a region with very fine clay above sandy material. Okay, clay, as it gets compressed, will actually allow water to leak out into the sand, and then we can pump water out from that sand. But because the water's no longer in the clay, the whole land above actually gets pressed down and becomes more and more compact. Okay, so in this way, the ground itself is actually shrinking as we're pumping water out. This is actually a large concern in some regions of California. So in this picture, they actually have posted exactly where the land was in different years. So at the top of the pole, it was in 1925. Okay, here in the middle is at 1955, and then down on the ground is at 1977. Okay, so the ground has slowly been sinking. Okay, so as water flows through the groundwater system, it can actually dissolve certain minerals, certain types of rock. Okay, particularly this particularly dissolves limestone. Okay, so as rainwater falls through the air, it naturally absorbs some carbon dioxide out of the air. This turns the rainwater slightly acidic. Okay, it's producing carbonic acid. This carbonic acid can then interact and dissolve the limestone. So if we have a region that is rich in limestone, then rainwater over time will actually break down rock, leading into these caves and caverns. Okay, so a cavern is just a really large cave. Okay, so over hundreds and thousands of years, the rainwater slowly eats away, producing these caves and caverns. Okay, a sinkhole is a funnel-shaped cavity caused usually by the ground being eroded away. Okay, so what can happen is you get a top layer of soil and then something happens underneath. So for example, rainwater dissolving limestone, okay, or possibly a lot of water activity beneath, okay, that eats away the ground below, and then all of a sudden the ground falls in, creating a giant sinkhole. Okay, so these are usually funnel-shaped openings. Okay, the ones that I've usually seen are really large ones, big enough to like eat a house. Okay, but all of these are caused as groundwater has removed material from below.